route summarization is one of the most important things that you can pick up when you're learning routing. No doubt about it. Route summarization. It comes with many different names. Let's list some of those names so that you aren't surprised, in fact, when someone says route summarization by another name. Let's give it another name. Route aggregation. Route aggregation, same thing. Can you think of another name? There is another name. It is the opposite of subnetting. Might call this supernetting. I don't call it supernetting. Why? Because that's not the Cisco convention. In Cisco, we would typically say route summarization or route aggregation. Now, what is it that we are doing when we say that we are summarizing? Well, first, why do we do this? It is the number one way that we scale any routing domain that is capable of being summarized. Let's qualify it. Because if you deploy an addressing scheme that is not conducive to summarization, then you can't do this. But assuming that your design is conducive, this is your number one way, and number two way, and number three way that you scale any dynamic routing protocol that is classless, which is RIP-v2, OSPF, EIGRP, Border Gateway Protocol. RIP-v1 is class full, and you can't control summarization. It just happens, and it's usually not good. That's a topic for another day. Route summarization. Okay, now I need you to understand the direction in which we are going. When we say that we're summarizing, we are making something generic, something less specific. So let's list off some networks, and let's talk about specificity for a moment. Let's say I have 10.1.32, and I'll do a /24 network, 10.1.33. Now, is that less or more specific than the 10 network? Is that less specific or more specific than the 10 network? Well, you know, those are really subnets of the 10 network. They would be subnets of 10.0.0/8. And the number that follows the slash is just the number of ones in our subnet mask. Prefix notation masks abound whenever we're talking about routing. So which direction are we going when we're summarizing? Well, it's the opposite of subnetting. When we subnet, we extend the mask. Do you remember that? Can you think about that? When we subnet, we extend a mask longer. And so let's look at this direction here. /8. Well, that's a very generic mask, and it includes anything in the 10 network. These have longer masks. They're more specific. They're smaller subsets of the 10 network, if you will. So if I were to subnet, I add ones to the mask. If I summarize, I peel back off those ones. And every time I peel back a one, I make a more generic, more open network space, a wider network space, if you will. Why do we care? Well, you see these networks over here on the left? I could represent all 8 of those with my routing protocol as 8, and it could be conveyed through the network as 8 unique, discrete, different networks. But that's cluttering my routing table unnecessarily if I can make a generic statement and encapsulate all 8 of those with one advertisement. I want you to look over here. 10.12.0/24. Compare. I want you to compare for a moment the /21 versus /24. That's a smaller mask, which means it's wider. It encapsulates more networks, more IP addresses. Now, what's great about this is not only do you reduce the impact in the RAM for your routing table, that's a minor impact. You also reduce convergence. You reduce the number of times that you converge, because guess what? If you have done this, if you've built a route summary, you have also hidden the specificity of those networks behind the summary. And if you've hidden the specificity of them, then you no longer need to say beyond the summary that network is up or that network is down. For instance, if I have done this summary, let's say one of the member networks has gone down. Let's say 2. The summary hides the specific, and router B will only see the summary. It's receiving the summary. It won't know that the 2 and the 3 networks are down. That's fine. This, in fact, is a good thing. It is adding stability. You wouldn't even send updates about those. So yeah, you're making a smaller routing table, but it's the number of updates being reduced and the reduced impact to Dijkstra's algorithm. That'll improve convergence, because let's say you got 5 updates right in a row. Well, the CPU is going to have to process those. If you get very few updates, then your CPU can work on just the ones that are relevant to the current network space. So route summarization is the process of taking a lot of networks that are suited for summarization, that are consecutive in order, and then representing them with one or more summaries. Now, I want you to get this in your mind. Sometimes there's not a perfect one-to-one. Maybe it takes 2 summaries to encapsulate the networks that you have. Maybe it can't be perfect, but maybe you can swallow up a range. But make no mistake about it, route summarization is our number one way that we scale any dynamic routing protocol.